So in section 4.2, we finally get into the actual trigonometry. 4.1 was was the geometry we needed. So 4.2 is called trigonometric functions, the unit circle. So the definition's it looks a little complicated here, but once we understand the picture here, it's not so hard. So definitions: let t be an angle, so they mean in standard position, and let xy be a point on the unit circle corresponding to angle t. Wow. All right. So unit circle, remember, that's a circle of radius 1 that's centered at 0, 0, okay? So let's start there, okay? So there's my xy axes. Let me draw a unit circle. So the circle of radius 1, okay? That's at 1, that's at minus 1, that's at minus 1, and that's at 1. So that's the point 1, 0, 0, 1, minus 1, 0, 0, minus 1. Right, so there's my unit circle. It's not perfect, but it's okay. So let t be an angle, so in standard position. So let me just draw, I'm going to put it in the first quadrant. It could be anywhere. So here's angle t, right, in standard position. Right, initial side is down here as always. Terminal side is here. Okay, so let t be an angle. Let xy be a point on the unit circle corresponding to angle t. Now, when they say angle t, they're referring to the terminal side. Now, where's the point on the unit circle corresponding to angle t? Well, angle t, the terminal side crosses the unit circle right there. So that's the point on the unit circle corresponding to angle t, and they're calling that point xy. Okay, now I don't know what x and y are, but there's angle t. Wherever it crosses the unit circle, that's the point xy. Okay, then the 6 trigonometric functions of t. Now I wrote them all out in the notes so you could see what the abbreviations stand for. Sine, cosine, tangent, cosecant, secant, and cotangent. So that's how they're written out long ways. So what are the 6 trig functions? Okay, once you have the picture, right, sine of angle t is that y value. That's all it is. So the sine of t is the y value. And the cosine of t, remember sin stands for sine, cos stands for cosine. Again, it's written out there. Cosine of t is the x value. Right? So those two are no big deal, okay? So here's an angle in standard position. Where that terminal side crosses the unit circle, the circle of radius 1, you call that point xy. Sine of that angle is the y value. Cosine of that angle is the x value. That's all it is. Now be careful. Writing sin equals makes no sense, okay? It's just like if you wrote square root equals 3. That makes no sense. You have to take the square root of something, okay? You have to take the sine of something, okay? So just writing sin equals 2/5 makes no sense. I mean, I always write a question mark there to say sine of what, okay? So you have to take sine of an angle and get it spits out a number. Cosine of an angle is a number. Okay, so sine is the y value, cosine is the x value. Now there are 3 others. Tangent of t, that we write tan of t, right? Tan of t is y over x. So you take the y value divided by the x value. Now obviously x can't be 0, because you can never ever ever divide by 0. 1 over 0 is undefined. 0 over 0 is undefined, it's not 1. You can never ever ever divide by 0, right? So if x is 0 and you put, I don't know, something over 0, the answer is tangent could be undefined, okay? Okay, so there's sine, cosine, tangent. Now cosecant of t is 1 over y. I'm getting ahead of myself, but notice sine and cosecant are reciprocals of one another. When you say 1 over something, that's taking the reciprocal. Secant of t is the reciprocal of x. And cotangent of t is the reciprocal here. It's x over y, but here you can't have y being 0. Because if y is 0, you're dividing by 0, and that's undefined. So there's your 6 trig functions. You just have to memorize, okay? So here's the point xy. It's cosine sine, right? It's cosine of t, sine of t. Tangent, right? Tangent's y over x. And if you can remember what's a reciprocal, be careful. Sine and cosine are not reciprocals. Tan and cotan are not reciprocals. Secant, cosecant are not reciprocals. It's sine and cosecant. So sine is y, cosecant's 1 over y. Cosine of t is x, secant's a reciprocal 1 over x. Tan is y over x, cotan's a reciprocal x over y. So notice, once you get sine and cosine, The other 4 you can get from those, right? Because y over x is just the sine over the cosine. Again, I'm getting ahead of myself, okay? So it's plugging and chugging. Once you get x and y, you just plug in the x's and the y's, okay? It's not that difficult. Now, what's the problem here? Okay, suppose, just for example, right? Here's the unit circle. Suppose I give you an angle of 10 degrees. Suppose I told you t, the angle t was 10 degrees, right? This is the unit circle. If that's 10 degrees, there's the point xy they're talking about. What are the coordinates of x and y? So if you make a triangle here, you go over x and up y. I have no idea what those numbers are. I don't have a clue, right? Now this is the definitions of the trig functions, but if I just give you a random angle, you can't figure out that point, okay? So for that reason, I mean, points like this, we're gonna do a different way in another section, okay? So they're doing other things here. So all I'm gonna do in this section, right? Let me not use 10 degrees. Suppose I use 90 degrees. Suppose I use 90 degrees. Right? There's the point. There's the terminal side. There's the point, the xy here. Could you tell me the coordinates of that point? Sure, right? Right? This is the point 0, 1. That's easy. Right? What about, could you give me the coordinates of that point? Sure, and that point, and that point. But if I give you one in the middle here, you know, what are the coordinates of that x and y for whatever that angle is? Who knows? Okay? So for this reason in this section, because of what I just explained, I'm only going to pick quadrantal angles to use the unit circle on. For the other things, we'll do in a later section, okay? So I'm only going to pick angles that stop on an axis, because if it stops on an axis, you can pick those 4 points, which are easy to identify. Okay? Now, like that 10 degrees, if you knew the x and the y, fine. You could find sine of 10 degrees, cosine of 10 degrees, etc., and plug in the x's and the y's. But if I just tell you that 10 degrees, you have no idea what that xy is, okay? So in this section, I'm only going to use the quadrantals. All right, let's do some examples. So I think I'm going to leave the definitions here. I mean, they have them in your notes. All right, it says evaluate each of the following using the unit circle. So we want sine of pi over 2. We want cosine of pi over 2 and tangent of pi over 2. Okay, so notice all 3 angles are pi over 2. So once you draw the picture for pi over 2, we can do all 3 problems here. Now where's pi over 2? We can do this in degrees or radians. Now where's pi over 2? Pi over 2, remember, is the same as 90 degrees. There's pi over 2. And what's the point on the unit circle at pi over 2? Right? It's 1 unit away, right? That's 0, 1. Okay, that's 0, 1. Well, once you have the coordinates, there's your x and there's your y. It's plugging and chugging, right? All the work is figuring out what the coordinates of that point. So what's the sine of this angle? So that's my t, right? That's pi over 2. Sine is the y value, 1. Cosine is the x value, 0. And tangent is y over x. 1 divided by 0 is undefined. I'm just going to write u and d for undefined. Very easy. Don't make this harder than it is. Now you have to know your definitions. Right? It's cosine sine. Cosine is x. You're tempted to say sine cosine, but it's cosine for x and sine for y. So sine of pi over 2 is 1, cosine is 0, tangent is that over that, y over x. And you can't divide by 0, so that's undefined. Well, that was easy. Okay, the next problem says, same thing, let's find cosine of minus pi, and let's find cotangent of minus pi. So again, we're doing radians here. Like, all these are radians on this first one. We could do this in degrees, right? If this had said sine of 90 degrees, it'd still be the point 0, 1. So sine of 90 degrees would be 1, cosine of 90 degrees would be 0, tangent of 90 degrees would be undefined. It's not the units of the angle that matter, it's just what point you're using. Okay, well let's draw a picture here. Now where's the angle negative pi? Remember, pi radians is halfway around, so negative pi takes me to here. Now on the unit circle, what's the point right here? We can easily identify that point. That's the point negative 1, 0. Because you went left negative 1, you don't go up or down any. Okay, well, cosine's the first, is the x, and sine's the y. So cosine is negative 1, first coordinate. Now how do we get cotangent of the angle? Cotangent's x over y. Notice cotangent is x over y. You're dividing by 0 again, that's undefined. Sometimes these are undefined. Notice sine and cosine aren't going to be undefined because x and y are just whatever the two numbers are. It's when you start dividing by things that you're going to may have a problem. What's the sine of minus pi? Well, sine of minus pi would be the y value, right? Sine is y, that would be 0. So if we did sine of minus pi, we would get 0. What's the tangent of negative pi? Tangent is y over x, so tangent would be 0. Okay, so once you identify the point, it's just plugging in. Okay, then the last little two here on this first page, it says find secant of 2 pi and find sine of 2 pi. Okay, so let's draw the angle 2 pi. Remember, 2 pi radians is all the way around, right? All the way around. So there's the terminal side. What's the point that corresponds to that angle? Well, that's the point 1, 0, isn't it? Move over 1, you don't go up or down any. Now let's do the sine, because that's easy. Remember, it's cosine sine, so sine of 2 pi is 0. Cosine is 1, right? Cosine is 1. What's the secant? It's 1 over the cosine, right? It's 1 over x and 1 over 1. So if they had asked for cosine of 2 pi, cosine is the first number, 1. And then secant's 1 over that. Easy. Don't make this harder than this. Now again, if I didn't give you quadrantal, if I gave you an angle out here, what would the coordinates of that point be? Who knows? Right, so I'm always using quadrantals. 1, 0, 0, 1, minus 1, 0, 0, minus 1. Those are the only problems I'm asking in this section. Okay, now I already alluded to this, right? So let's write it out formally. Again, it's in your notes. I'm not going to write them all down. But I already made the observation that sine and cosecant are reciprocals of one another. So cosecant of an angle t is 1 over sine of t. And likewise, sine of t is 1 over cosecant of t. They're reciprocals of each other, right? The reciprocal of sine is 1 over y. The reciprocal of cosecant, that's 1 over y. When you invert and multiply, you get y. Okay? So all those 6 identities, the reciprocal identities, are saying sine and cosecant are reciprocals of one another. Cosine and secant are reciprocals of one another. Tangent and cotangent are reciprocals of one another. That's what those 6 things are saying. Right, so what they're using thetas there. So tangent of theta is 1 over cotan theta, and cotangent theta is 1 over tan theta. All that's saying, those two, tan and cotangent, are reciprocals of one another. Okay, that's not true. That's not just true for quadrantals. That's true for any angle. But again, in this section, I'm just doing the quadrantals. Okay, so the next part is using the calculator. So we don't need this picture anymore. To do the calculator. Okay, so it says use the calculator to find each of the following. Let me write them all down. So sine of 22 degrees, 16 minutes, 38 seconds. And B is secant of 24 degrees. C is cotangent of 21 degrees, 57 minutes. And then the last one is 1 over cosecant of 28 degrees. So we're supposed to use a calculator. So this is an example. Notice none of these are quadrantal angles. So if I sketch the picture of this angle, if I did 22 degrees, 16 minutes, 38 seconds, here, I have no idea what that point is, right? So cosine would be x, sine would be y, but I have no idea what that point is, okay? So I'm going to use the calculator here. So we just need to punch this in. Now, the first thing you need to watch out for is on your calculator, all of these are degrees and minutes, so there should be a setting on your calculator for, on the TI-83 or 84 plus, it's under mode, right, which is up here. Your calculator, you may have to look in the manual somewhere, make sure, right, for these, you're in degree mode. Okay, you might be in radian mode. We've talked about radians, but none of these angles are in radians, okay? So when you're taking sine of something or tan of something or cosine of an angle and it's in degrees, you need to be in degree mode in your calculator. Okay? Okay, so you may have to pause the video and look at your manual to change your calculator mode. if I'm going to do this problem, and if you don't get the same answer I do by typing the same thing and I do, you're in the wrong mode. That'll be a dead giveaway. Okay, now, so I'm in degree mode, which means my angle needs to be in degrees. This is in degrees, minutes, seconds, but we've talked about how to do this. All right, so I'm going to type this in as 22 plus 16 over 60 plus 38 over 3600 degrees. Now you don't have to write this down, right? But just be aware, that's how I'm typing this. And you don't need the degree sign. I'm in degree mode. The calculator knows I mean degrees, right? So I don't have to write the degree sign. I just wrote it there because it's degrees. So sine of, it automatically gave me parentheses, 22 plus 16 over 60 plus 38 divided by 3600. Okay? Sine of 22 plus 16 over 6 plus 38 over 3600. And I got 0.3791 if I round to 4 places. Yeah, and the instructions say round to 4 places. So 0.3791. So if you type this in exactly the way I wrote it here, but you don't need the degree sign, you should get 0.3791. So if you didn't get that, you're in the radian mode. You need to find how to change your calculator to degree mode. Oh, and again, there's the sign button. You should have a sign SIN button on your calculator. That's why we were able to do this. Now look at the next one, secant of 24 degrees. Now most calculators, if you look at yours, I do not have a secant button. I have a sine button, next to it's a cosine button, next to it's a tangent button. Now why don't I need a secant button? Because you can write secant in terms of cosine. Remember, secant, cosine are reciprocals of one another. So the way to type this is secant of 24 degrees, it's 1 over cosine of 24 degrees. Notice the angle stays the same. It's not 1 over 24. Okay, be careful. The angle stays the same. Secant is a reciprocal of cosine. So this is what you need to type in. Again, you don't need the degree sign because you're in degree mode. The calculator knows it's 24 degrees. So 1 divided by cosine 24, and close out your parentheses, is the 4 places 1.0946. 1.0946. And so again, if you're in degree mode, that's the answer you should get when you type it in. So secant of 24, there's no secant button, so you have to think of it this way. Type this in, and that. So the secant of 24 degrees is 1.0946. Okay, now what about this one? This is a combination of our previous two problems. There's no cotangent button. But remember, cotangent and tangent are reciprocals of one another. So this is 1 over tangent of 21 degrees, 57 minutes. So how are we going to type that in? Well, the 1 over tangent is no problem. I have a tangent button. But this is degrees in minutes, so you have to do this to it. So I'm going to type in 1 over tangent of 21 plus 57 over 60. Okay, so 1 divided by tangent of, parentheses, 21 plus 57 divided by 60, parentheses. 1 over tangent of 21 plus 57 divided by 60, close out your parentheses, and I get 2.4813. 4 places, 2.4813. Again, hopefully you're getting these same answers I am. So again, to type this in, I did 1 divided by tangent of, parentheses, 21 plus 57 over 60, parentheses. Right, now this last one, they're trying to be tricky. Well, I say they. I apparently made up this problem. Okay, so what you could do, remember, there's no cosecant button, but cosecant's a reciprocal of sine, so you could think of this as 1 over sine. But that's complicated to type in, right? You can invert and multiply. Sine and cosecant are reciprocals. This is saying 1 over cosecant, that's the reciprocal of cosecant. The reciprocal of cosecant is sine. So all that is sine of 128. Again, if you want to, this is 1 over sine of 28, right? Cosecant's 1 over sine. But if you invert and multiply, you'll just get sine. But the easiest way to think about this, 1 over cosecant is the reciprocal of cosecant. The reciprocal of cosecant is sine. Again, the angle stays the same. Don't take 1 over the angle. So this is the same thing as sine of 28 degrees. We have a sine button. So sine 28, 4 places is about 0.4695. You have to round up, 4695. Okay, so the calculator isn't so bad. You just have to practice using the calculator. And again, from here on out, before you type anything in the calculator, when you're taking sine of an angle, cosine of an angle, tan of an angle, you need to check your mode. If these were in radians, we'd have to be in radian mode. They're in degrees, so I was in degree mode. Now, if you're just adding numbers, 2 plus 3, mode doesn't matter. Mode only matters when you're taking sine of something, cosine of something, tan of something, etc. Okay? Then the angle, it depends on your mode. Okay, so then there's the next idea here. So we have our 6 basic trig functions, and we've noticed how they're related to one another. Some of their reciprocals. Okay, so this last idea here is consider the following picture. Okay, let me go back to the unit circle we were talking about. I didn't give you much room, so you have to write small. So here's my unit circle. All right, and let me just pick an angle theta here. I was using t's before, I'm going to use theta here. Right? So here's angle theta, right? And there's my terminal side. And there's the point xy that corresponds to, it's the point on the unit circle corresponding to theta. Right? Let's look at sine of theta, and let's look at cosine of theta from this picture so far. Well, remember, we know the cosine of theta is x, and we know the sine of theta is y. I mean, that's from before. No problem. Now, I don't know what, depending on the angle, I may not know the coordinates, but I know, if I call it xy, sine is y, cosine is x. Now let me add to this picture. Instead of drawing theta, let's draw a negative theta. So it's the same number, it's just the negative. So if this is 10 degrees, I'm going to do negative 10 degrees. This is, pi over 7, I'm going to do minus pi over 7. Now it's going to be symmetric here. It's, whatever angle that is, it's going to be the same angle coming down, right? So this is the angle negative theta. So again, if that's 10 degrees, this is minus 10 degrees. If that's pi over 8, that's minus pi over 8. All right, so this angle is going to cross right here. Now, what are the coordinates of that point going to be? Again, my picture is a little cattywampus here, but I mean, there's symmetry going on, right? Whatever that goes up, that goes down. It would make sense that this point here is going to be directly below that one, isn't it? Because of the symmetry. Because these two angles are, I mean, in terms of the angle itself, ignore the negative. Positive is up, negative is down, but that angle is the same as that angle, except for the rotation. So what would the coordinates of this point be if that one lies directly below this one? You would move over x and go up y to get this one. Notice x is the same. You still move over x. But instead of going up to y here is positive, you would go down a negative y, wouldn't you? Right? If that's the point 2, 3, this would be the point 2, minus 3. So when I write x, y in the first quadrant, they're both positive, right? So that's a positive x, and that's the negative of that. So let's look at this. What is the sine of negative theta and the cosine of negative theta? So now I'm using this angle here. There's the point corresponding to the terminal side of the angle. Cosine's the x value. And notice sine is this y value, which is minus 1. Okay? And we could do all 6 trig functions, right? But I'm just using these 2, the basic ones. Because remember, you can get all the other 4 trig functions from these 2. Now, so how are these related? How does sine of, let me do cosine. How does cosine theta compare to cosine of negative theta? Notice they're the same. So from this observation, I see that cosine of negative theta is the same as cosine theta. Now, I drew the picture, I drew theta in the first quadrant, which meant negative theta was in the fourth. If I had drawn theta in the second, negative theta would be down here in the third. Once you do the picture, you'll get the same relationship. You'll see they're the same. Right? Now, how does sine of negative theta compare to sine of theta? Notice they're not the same. They're off by a minus sign. Sine of negative theta is the negative of sine theta. Now, do you see how the operations work? Here, you take whatever theta is, you take the negative of theta, then take the sine of it. Here, you take the sine of theta, and then take the negative of it. So notice you're taking the negative of the angle, then doing the sine. Here, you're doing the sine, then taking the negative. Now again, if theta is in the first quadrant, x and y are both positive, and negative theta would be in the fourth quadrant, and x is positive, y is negative. Again, if we're in a different quadrant, if you rotate different ways and that sort of thing, over here, the x would be negative, and the y would be positive. Here, x is negative, y is negative, right? So I'm not saying this is always positive and this is always negative. It is in my picture because I put theta in the first quadrant. So sine could be negative here, if y is negative. The negative of that would then be positive. So they're opposite signs, S-I-G-N. They're opposite signs in a line. So this is what we showed. Now, maybe you remember from college algebra that when you have a function, when f of negative x is f of x, we call the function even. And when f of negative x was negative f of x, we call the function odd. And remember, the graph of an even function is symmetric about the y-axis. The graph of an odd function is symmetric about the origin. If you rotate the graph 180 degrees, you get the graph back. And so notice cosine is an even function. F of x here is cosine x. So cosine of negative x is cosine x, right? Even. Sine of negative x is minus sine of x. Odd. So sine's an odd function, cosine's an even function. So we'll see that later when we get to the graphs. Okay, now that we know these two facts are true, the next example says, use these two results to find similar theorems for the other trigonometric functions. Okay, well, for example, let's look at tangent. So I'm interested in tan of negative theta. Now, I could have done tangent here and gotten the result just like we did here, but I'm trying to emphasize the fact that once you know sine and cosine, you can get the other four trig functions. So what was the definite? Well, we know that tangent of negative theta, right? I mentioned this before. We haven't officially covered it, but tangent of negative theta is sine of the angle over cosine of the angle. We mentioned that before, because remember, cosine was x, x, and sine was y, and remember, tangent was y over x, so that was sine over cosine. Right, so we haven't formally done that, but that's what it turns out to be, tangent sine over cosine. Right, tangent of this angle is sine of that angle over cosine of that angle. But what's sine of negative theta? We just said it was negative sine theta. And cosine of negative theta, we said was cosine theta. Right? I'm just using those here. So sine of negative theta is minus sine theta. Cosine of negative theta is cosine theta. Well, you can pull the negative out front. And what is sine of theta over cosine of theta? Sine of an angle over cosine of the same angle is tangent of that angle. So notice tangent of negative theta is minus tan theta. It works like sine. Right? So tangent is odd, just like sine is. Okay. I say to find for the other trig. Yeah. Okay. So there's tangent. All right. So let me do cosecant, and then we'll just talk about the others. So what if I wanted to do cosecant of negative theta? Right. I know what these do. How can I write cosecant in terms of those? Well, cosecant is the reciprocal of sine. This is 1 over sine of negative theta. Remember, the angle stays the same. Cosecant's the reciprocal of sine. But sine of negative theta is the negative of sine theta. So notice I'm using this to figure out cosecant. You can pull the negative all the way out front. And what's the reciprocal of sine theta? It's cosecant theta. So notice here, the angle is negative theta, so it's 1 over sine negative theta. This is 1 over sine theta, so the reciprocal of sine theta is cosecant theta. Remember, the angle stays the same. So that angle had to be that angle, and that angle had to be that one. But I use this one to pull that negative out. So notice cosecant of negative theta is minus cosecant. It works the same way as sine. So, I mean, you could do this with all the others. So, sine, we just saw sine and cosecant behave the same way. The negative pulls out. Tangent pulls out. Cotangent pulls out. Cosine and secant, it's reciprocal, right? Maybe I should do that. Let me do secant. So, secant of negative theta, that's 1 over cosine of negative theta. Secant, cosine are reciprocals. The angle stays the same. But cosine of negative theta, that's cosine theta, isn't it? From that, I replaced that with that. But what's 1 over cosine theta? The reciprocal of cosine is secant. The angle stays the same. So secant of negative theta, secant works like that. So secant and cosine are even. The other 4 work like this. The negative sign pulls out front. Okay? Okay, so if you just remember, cosine and secant do this. The other 4 do that. Okay? You have to memorize certain facts, in math, But you try to minimize and memorize it. I know secant and cosine do this. They're even. So secant of negative theta is secant theta. Cosine of negative theta is cosine theta. The other four, tan of negative theta is negative tan theta. Cotan of negative theta is negative cotan theta. Okay, so if you just remember secant and cosine, do that. The other four do that. Okay, let's do the last example here. It says, suppose sine of negative t is 3/8. Okay. So the question says, find sine of t. Right? Well, what's the relationship between sine of negative t and sine of t, right? They're off by a minus sign. Right? Sine of t and sine of negative t, they're off by the minus. You could put the negative sign here if you wanted to. It doesn't matter which side you put. Multiply both sides by -1, you have minus sine minus theta sine theta. I just remember they're off by a minus sign. So how do sine of negative t and sine of t compare? They're off by a minus sign. Since this one's positive, that will be negative. Right? If this had been negative, that would have been positive. Right? So that's what it memorizes. I mean, sine of negative theta is minus sine of theta. That says sine of theta and sine of negative theta are off by a minus sign. It's not saying this one's necessarily negative. They're off by minus sign. So if this had been negative 3/8, that would have been positive 3/8. Well, that's the first part. That was easy. Then the second part says, find cosecant of t. How are you supposed to get cosecant from all this mess? Remember, cosecant of t and sine of t, it's the same angle. They have to be the same angle. Sine of t and cosecant t, what's the relationship? They're reciprocals of one another. So cosecant t is a reciprocal of sine t. So that's minus 8/3. Just take the reciprocal. So the new part was going from here to here. Sine of minus t and sine of t are off by a minus sign. Cosecant of t is a reciprocal of sine of t. So it's just a reciprocal of that. Okay, that's section 4.2.